Bonjour à tous et à toutes et bienvenue à la grande conférence de l'Octobre Numérique organisée par IVADO et en direct de Montréal. Hello everybody and welcome to the Keynote conference of the Digital October organized by IVADO and titled, wait up, it's a long title, Quebec at the Forefront, Machine Learning and Operations Research, a winning combination. So this conference is brought to you live in Montreal, Quebec. My name is Natalie Sanin. I'm head of the IVADO training program, and I will be today your designated moderator for this online conference that is actually the starting point of the great event, new event. It's the first time we organize it, the Digital October series of events, where all the students are the stars and their very innovative projects are at the forefront. We definitely wanted to start this event this year in a grandiose manner. And so we have a very exciting lineup for you today. But just before getting to our presenters, I'll go through some quick kitchen notes. So we will definitely accept your questions, and please do so. Please submit your questions, and you could do so right here. I think you can see that there is a Q&A section where you could write your question, and we'll try to answer them as much as possible at the end during the Q&A session. Just make sure to write the name of the person to which this question is destined to. Also, and this is for our panelists, we ask that you definitely respect the conference rules. So please, no rude interruptions, okay? No rude interruptions, and please, no personal insults as well. We do not accept them here today. I'm not sure why I'm saying that. Maybe I saw something on TV lately that was very disturbing. All right, let's go to our panelists. So first of all, I would like to present to you Emma Frejinger. She is a professor at Université de Montréal, member of the IVADO Scientific Committee. She is also holder of the CN Chair in Optimization of Railway Operations. Emma, thank you for being here.
Thank you.
Also, we have the great pleasure to have today Andrea Lodi. Andrea is a professor at Polytechnique Montréal. He is also co-scientific director of IVADO, also holder of the Canada Excellence Research Chair in Data Science for Real-Time Decision-Making. Andrea, thank you so much for being here.
Thanks, Natalie. Happy to be here.
Yes, great. And finally, we also have Yoshua Bengio with us today. Yoshua is professor at Université de Montréal. He is also scientific director of Mila and IVADO. And he is also holder of the Canada Research Chair in Statistical Learning Algorithms. Yoshua, thank you so much for being with us today.
My pleasure.
So
Thanks
we
for
know
organizing
that,
this.
Yes, with pleasure. We know that you will have to leave at some point, but before you leave, we'll definitely make sure that Yoshua answers some of our very, very tough questions. Not at all. Okay, so let's start. We're ready to start with the first questions. So as you saw in the title, we're talking today about machine learning and operations research. So let's maybe start by explaining a little bit each separately. What is it and what does it mean? So Yoshua, everybody's really talking about machine learning these days. It's very popular. What is it exactly? And can you actually give us a little bit of background?
Sure. So in order to take decisions, which is what operations research is really about, you need knowledge, right? So you can take the right decisions. And machine learning is basically about acquiring knowledge. So how does an agent, like a human being, an animal, or a robot, figure out what it needs to know from the world? And in general, the way we think about this in machine learning is we're going to observe things from the world, but sometimes you can also interact with our environment. This is called reinforcement learning. And through the data that we get, we usually will build like predictive models or decision functions that optimize some objective, like we're trying to get the errors of prediction as small as possible. And then we have optimization methods to help us find the right functions, the right parameters of these functions in order to best model that data that allows the agent to figure out what it needs from the world.
Okay, so that was talking about machine learning specifically. Another, on the other hand, operations research is something that we seldom talk about. To tell you the truth, I hadn't heard about it before coming here at IVADO. So how come why is operations research much less addressed in the general public? And what's the background for operations research? Andrea, do you want to go on that one? Yeah.
Yes. So operation research is a discipline that is definitely around for quite some time now. I mean, originally it started during the Second World War, in which the group of people coming from physics, coming from mathematics, and several other engineering disciplines got together and tried to solve problems that were actually relevant for the Allies. And especially the first problem has been the location of radars into the UK territory in order to minimize the influence of the bombing from the Germans and the Nazis. So from that point on, the discipline has been developed steadily, and actually came to our times. So I would say that's almost 80 years that the discipline is around. It's definitely a bit less fashionable than what machine learning has been in the last few years, but the influence in industry and the influence in applied mathematics from the scientific perspective has been very strong for the entire time. So I would say that some of my friends and colleagues are saying that discrete optimization in general, is actually a well-kept secret of why, let's say, industrial applications are actually solvable. And I think this is partially true. So on the other hand, the continuous optimization part, as Yoshua was pointing out, is definitely even inside machine learning. So the two disciplines are actually close together.
So they're close together, but operations research kind of kept to itself in a little. Are there a lot of people working in operations research, or in academia, for example?
I mean, definitely so. I mean, many of the industrial engineering departments are together, especially in the US, are industrial engineering and operation research. This is actually happening even at Polytechnique, the department in which I am. It's mathematics and industrial engineering, but I mean every essentially engineering school, but also mathematical school, and it's in statistics in the departments of economics. So somehow it's actually spreading quite a lot around, and of course in computer science. But I mean it's spreading quite a lot around the many areas of let's say, of science and disciplines of this type.
Okay, so we heard a little bit about machine learning. We heard a little bit about operations research. So the interesting that's happening today, and that's the reason why we're here now, is that there's kind of a merge of those two disciplines in academia as well as in industry. So Emma, can you tell us what happens when you combine those two, machine learning and operations research? Tell us about the magic.
Yeah, sure. So I think actually one can say that they're interacting now, and this is definitely something, maybe magic going on. But as Yoshua was mentioning, actually nonlinear optimization is kind of part of machine learning since a long time, and it has been used in combinations, but not in the way that it's done now. And I think it's thanks to the tremendous success there have been in machine learning, but also the advances on the algorithmic side, on the operations research. That means now that when we combine the two and we're putting these pieces together, we can solve problems that we could not solve before. There could be like two reasons for why these are new. Either these are like problems that we can solve in a time which is a lot shorter than we could solve them before, or that we can tackle problems, so decision-making problems that are a lot harder. So then I'm thinking about these OR problems that Andrea was mentioning, that are typically too hard or too time-consuming for humans to solve. So you need algorithms to solve them. But even algorithms have their limitations. And when we kind of put these two pieces together, we can solve increasingly complex problems. So I would see that is kind of part of me, at least, the magic, that you can do things that you could not do before when you're combining these two.
Mm-hmm. I saw on your webpage, Emma, that instead of talking about machine learning and operations research, you actually talk about statistical learning and operations research. Is it the same thing, or is there a difference there?
So I would say maybe statistical learning is used a bit in a broader sense than machine learning. But these are, part of statistical learning is machine learning. I usually refer to statistical learning because there are also englobing methods more that maybe one would refer to as classic statistics, which are actually an important part of operations research applications when you're combining the two, because it's not usually this combination is just not that you take one thing from one field and you take one from the other and you combine them and they suddenly work, right? It's not as easy as that. And so you need to combine them in a way that makes sense and make these pieces work together. Yeah.
Mm-hmm. Okay. So then...
Sorry, Nathalie, if I can add something related to this, and I think to both the things that we are saying in both machine learning and optimization, the way of making them communicating even more is actually through data, right? I mean, this has been the last at least 10 or 15 years, big innovation that led both our disciplines, machine learning and optimization, to become more and more successful in the possibility of solving real-world problems.
Okay, so is it a correct assumption to say that machine learning actually helps understand the world, whereas operations research helps the decision-making process? So that's generally what we say about both of them. But then for the combination of the two, could it be that this new combination, I don't even know, does it have a name? Do you have a name for this? Or do you always call it combination of machine learning and operations research?
We call it IVADO.
I love that. I was thinking more MLOR, MLOR maybe, that could be the name, or IVADO if you prefer. So this combination of the two, can you say that it helps us make accurate decisions in a world that's getting more and more complex?
And a world that is changing, right? So you want to be able to quickly figure out what should we expect from the near future if I'm going to plan some decisions in the near future. But for that, you need to understand how things tend to unfold in the world and how they might change.
Okay.
Yeah. On the one side, I would say that in the past, when discrete optimization and operation research, sometimes I'm going to use discrete optimization because actually I'm coming from that side of operation research. Discrete optimization means that some of the decisions that I'm supposed to make by solving the problems and using algorithms are discrete decisions. So buying or not buying something, right? I mean, this is a 0-1 type of decision. It's not a continuous decision, but is a discrete one. So I was saying that, as discrete optimizers and applied mathematicians in the past, what was happening is that they were actually exposed to some applications, and those applications we were solving them by actually looking at the model part and rarely looking at the data, because it was difficult to actually getting good data in the past about the application that you wanted to solve. Now the situation has changed radically. Then when you talk to a company, the company was going to dump you a lot of, let's say, unstructured data and telling you to get a sense out of it. And of course, this is the part in which Yoshua was pointing out as knowledge acquisition. You want to understand what the data is telling you, and predicting what is going to tell you tomorrow, right? I mean, this is the part that is the most important one. And then once you have done this kind of prediction, then the models that we used to develop and the models that we are actually started to develop even more recently are much more informed on the decision that they need to make.
And one thing I'd like to add is about unstructured data. That's kind of new, right? Machine learning is now able to handle things like text, images, sounds, all kinds of signals. Whereas, with previous statistical methods, it wasn't obvious how to deal with those.
Okay, I see. So, Andrea, you were mentioning the fact that companies are using their data. And so, in this case, we've heard a little bit of background about machine learning, a little bit of background about operations research, a little bit of background of the magic of what happens when you put the two together. So can you give us some concrete examples of applications in industry and maybe also in academia so that we really understand for each of them, what does it look like in the real life?
Yes, so the applications that operation research has been concerned since the very beginning. One I mentioned is this location of radars. Location in general means putting the resources or the facilities in the right place in order that the people can actually have access, people and companies or whatever. I mean, anyone that needs a facility to be able to access it at the right time. And this is one area that is, kind of universal in the sense that is used for transportation, but is used for telecommunication, placement of antennas. And of course, in order to having a good coverage of the telecommunication side, there is the scheduling, of course, of personnel in a call center. Of course, you want to have the right resources at the right time in the right place, but also scheduling of personnel on transportation or personnel on any type of areas in which you need people and you need resources. And of course, there is a lot going on in healthcare in terms of logistics, of course. So how to move things and making sure that, I would say, the resources are available at the right time. This is called the supply chain in a certain sense. So when you start by the time in which you conceive a certain product, and then you want to buy the raw material in order to produce it, and then the time in which you want to schedule the production, and the time in which you will deliver the product to the warehouses, from the warehouses to the clients. So this is the overall chain of supply that you need to solve, and these are definitely applications in which not only operation research, but actually the combination between operation research and machine learning has shown to be extremely successful to deal with.
Yeah, but exactly, that's the thing. I really want us to really understand what's the difference between the operations research, the way we were doing it before the advent or the adding on of machine learning. So specifically, just give one example of pure operations research without any machine learning, just so that afterwards we really see the difference.
Emma, do you want to take this one?
Yeah, I can take this one. So I can think of one of my the problems I'm very passionate about, which is the design of transport systems. So I'm interested in the design of transport services. So you can think about, whatever app you're using, not to mention specific names of companies, but now you have all these kinds of services, right, that you can have access to. And so when we're talking about transport design, we're talking about how should we, a kind of schedule services, what should be a bus schedule, what should be, what are the services you have access to. So if I'm going to solve this problem and I ignore the machine learning part, I can say I'm going to put a bus schedule, and I don't know what people really want. So I'm just going to assume that every day there is a fixed number of people who are going to come and they want to go by bus. Okay, and I solve this thing in isolation. So I'm saying, I'm going to fix what I believe people want, which is the demand, and I'm going to do my schedule. And then there is no machine learning there. I'm just magically getting this number where I presume that I have X number of people who want to take the bus no matter what. Now I can have a machine learning algorithm predicting what is actually people's desires, what are their preferences. Maybe they have different options. They can use their cars, they can use some bike sharing, their car sharing, their buses, and so forth. And depending on how I'm doing my schedule, more or less people may want to take this bus. Okay, so now I suddenly have an optimization problem where I'm going to find a good schedule, but I will not only try to find a good schedule assuming that everyone will want it no matter what, right? I want to find a schedule that finds the sweet spot between what are the needs and preferences of people and how should I best accommodate that with my schedule, and obviously taking into account what it costs to have these buses. I cannot afford maybe to have buses too often and so forth. So now I was taking the example of a bus, but you can imagine that this can be scheduler in a general sense. Does that answer make things clearer? Like,
yeah, definitely. So now we saw the difference between pure operations research, and with adding the machine learning part. What about pure machine learning? No operations research. Yoshua, can you give us an example of, an application with pure machine learning, but that does not have any operations research?
Well, almost everyone uses applications that with machine learning inside, whether it's on your phone, your search engine, like Google, recommendation engines like Amazon, Netflix, Facebook, Twitter. So all of these guys, which are probably the richest companies on the planet right now, they use machine learning to better understand documents, images, and how humans will react to what is proposed to them. So, for example, a search engine wants to be able to see if when somebody types is semantically related to what is found in some document, even if it's not the same words that are being used. And maybe if it's an image search, it wants to make sure that the content or the visual content of the images matches what is being typed. So for that, you need some kind of understanding of what is going on in these images. What are the objects that are present in these images? Your phone was probably one of the first uses of deep learning was for speech recognition. It started around 2012, I think. And if you had Android, you could use neural nets to recognize your voice on your phones. Now the progress has been such that basically the technology of speech recognition was not usable before those years, and now it's still imperfect, but it's pretty darn good. Machine translation is one example of application that I've worked on, which actually involves some discrete optimization, but it's mostly machine learning, where you want to take a sentence in French and create a sentence in English that has the same meaning.
Or in Creole.
That's right. That's right. Yes.
I actually saw this week. I saw that it was possible to translate into Creole, and I was so happy. I'm from a Haitian origin, of course. I'm sorry I interrupted you. Go ahead.
No. In fact, one of the interesting research problems in machine translation these days is how do we deal with languages for which there's very little data? Of course, English or French, there's a lot of data. But there are a lot of languages on Earth for which there's very little data. And how do you train a machine to understand those languages with so little information? So it's a lot of interesting research questions, which connect to some of the basic fundamental questions of machine learning that come from AI. Like, how does, for example, a child learn so quickly from just a couple of years of life to understand language, to understand visual imagery, and so on? These are really fascinating questions.
And also using much fewer examples, a child can actually learn. Yeah, that's fascinating. All right, so now I think we understand a little bit more the difference between the two, as well as the mix of the two. So at least I understand better.
We just talked to you.
Yeah, there's no one else, actually. This event was not popular. So this is an event for students, basically, mainly for students. We have other people watching, of course, but mainly for students. So let's talk a little bit more about your students, the students coming from your lab. I think for a professor, it's probably very important to see that your students have become themselves also professors and that are continuing the great work in fundamental research, which is very important. But thinking in terms of tech transfer, so is there a particular project that was initiated in your labs by a student and that probably became, gave way to a startup or to perhaps a product that was commercialized? Yoshua, do you want to go with that?
Yeah, I'll talk about just two examples, but there's been at least a dozen of my students who have started companies. So one of the best known in Montreal, of course, is a company called Element AI. And one of my students, Nicolas Chapadot, was one of the co-founders. And Nicolas has been passionate about time series since he started with me in the late 90s. It's a long time that we've been working together. And it turns out that analyzing time series is a very important activity for companies. They have company records, they have data from their customers. So that's one of the things that Element AI does, applying machine learning for all kinds of industrial and business applications. Another interesting case I want to mention is Eugene Surban. So he also did his PhD with me, but co-supervised with my colleague Aaron Corville. And Eugene has been for many years passionate of how AI could help education, to help students. And so he created a company that uses machine learning to help students learn more about their topic using dialogue systems. So during his PhD, he's worked on how computers can use natural language to dialogue with a human being. There's still a long way to go, but the progress has been pretty nice in the last few years. And so that's enough for solving these kinds of problems, which I think could really have major impact in the world to democratize education or to complement existing education where the professor doesn't have the time to spend with enough quality time with every student. And so could imagine a model where both you have personalized education with an AI tutor and you have interaction with a real human being, which I think is essential, at least from a psychological point of view.
I think you're talking about Corby, right? I don't know if I
That's
can
right.
say
Corby.
name. Yeah, it's Corby. Yeah, so I've heard about that. That's a great platform indeed. Being in, myself in formation continue. So, Andrea, would you like to tell us a little bit about some of your students?
Yes, I mean, this is definitely one of the biggest, definitely, or the deepest reason for which we're doing this work. And we stay in academia is that because we see that our students are bringing the legacy of what we are doing into both, keeping it in academia and both bringing it to industry. And many of my students are actually involved in software development for discrete optimization solvers. So like IBM has a solver called Cplex, then FICO is a big company as well as another one called Express. Then there are open source ones. And Andrea Tramontani is one of my former students, is actually one of the biggest contributors. Cplex, you have students in pretty much all the solvers. Mosaic is another one, and Sven Wiese is another one of my students. More recently, we started something in Montreal called the IVADO Labs. IVADO Labs is a supply chain, it's concerned about supply chain, is AI and it's connected to the supercluster in AI-powered supply chain. So it's the idea, as I was saying before, is to connect, let's say, AI methods, machine learning and optimization and discrete optimization for solving supply chain problems. And on this company that I contributed to found, there are actually already some of my students heavily involved, like Theodora Dan, for example, and that are playing a good role, so the big roles as data scientists there.
Okay, good. Emma, I imagine that you have students, but maybe they haven't gone themselves to become professors yet. Is that?
That's the nice way of saying I'm slightly younger than the two other panelists here. Yes, of course. I mean, being in academia, the big privilege is actually to work with students and seeing them grow in their role, starting and also I think students bring a unique view on problems. They come and with fresh ideas and so forth. So it's really nice to work with students and see them grow. Some of them continue. I have one student, Tien Mai, who came from Vietnam to study here in Montreal, and who barely spoke English when he started out. And he won actually one of the most prestigious awards for his dissertation that was at their intersection between machine learning and operations research. So he won that award from an operations research society called Informs, and he's now a professor. So for sure, I mean, seeing and me who have not been around as long, it's nice to see students becoming professors. And as Andrea mentioned, I've also student Mael Zimmerman, who is one who also started to work from this company, IVADO Labs, that I'm also involved in. And otherwise, there are students also, some who start doing a PhD, but they don't necessarily see themselves continuing in academia. And then they're interested in working on really, real world applications. And then they would typically work on industrial projects. So for instance, the collaboration I have with the Canadian National, the railroad company, they would work on scientifically challenging problems, but that are part also of a challenge for that particular company. And then they would typically pursue an industrial path after their studies. Yeah.
Okay, nice. So indeed, this event is definitely a student event, as I said before, but I'm repeating it because it's so important to IVADO, the students. And so I just want to let the people know that if you want to have a sneak peek of all the nice, innovative projects that are going on and that are being done by students, make sure to be part of this Digital October going on throughout the month of October, of course, where you'll see a lot of nice presentations, such as, and I chose just a few just to give you a sneak peek. So Sébastien Henwood, for example, that has a project called titled For an AI, Low in Energy Consumption, ou en français, pour une IA à faible consommation d'énergie. I'm having a little bit of trouble. Or, for example, Laura Galliano, and this is a subject I'm really interested about, seizure forecasting to improve management of refractory epilepsy. Now, let me tell you something. I used to work on epilepsy without all these nice tools. We weren't into seizure forecasting. We were just trying to have some seizure detection. So this is definitely a subject that I'm very anxious to go here. Also, Kaba Sekou Umar, who has a project titled Deep Learning for Material Discovery. Or also Francis Banville, who has a project titled Prediction of Interspecies Interactions in an Ecological Network. And of course, you'll see many, many more. So don't hesitate to go hear it out. There's 4 main teams, actually. The first one being Smart Cities and Societies, that will be addressed on October 8th. The second one is Health and Digital Intelligence, that will be addressed on October 15th. The third is Algorithms of Tomorrow, that will be addressed on October 22nd. And the fourth is From Earth to the Other Planets, that will be addressed on October 29th. So definitely make sure to go hear them out and encourage them. All right, let's get back to our panel. Let's get into kind of some technical aspects. For me, they're technical because I'm kind of lost in all this, although I do understand a little better now. But let's define some technical terms. There are terms that I see a lot, and I'm not sure what they mean. Maybe you can, enlighten us in this. Predictive versus prescriptive analysis or analytics. Which applies best to the combination of machine learning and operations research, and why? Who Who wants to go? Maybe Yoshua?
Well, I'll take the predictive part.
Go ahead.
As I said earlier, like one way to train a machine learning system so that it understands something is to force it to make predictions and then check its predictions and then train it so that it gets the right prediction. So machine learning systems, not always, but are often used to make predictions. They can do, say, also back predictions, like, what is it that explain what happened or whatever. But often you're trying to predict one thing given other things. These are called conditional probabilities in our jargon. And they become very useful, of course, with operations research. But I'll let Andrea or Emma complete that.
Well,
right.
the predictive versus prescriptive is the way in which the people wanted to see it in that sense. And Ivado is exactly saying, as if you wanted that predictive and the prescriptive, not versus, but they stay together, right? I mean, the knowledge acquisition that we were talking about is the predictive part, and the decision making is the prescriptive part. So prescriptive analytics for the community means that you want, you want to say to decision maker, give them information and give them options in order to make the right decision. So, and then prescribe some sort of decision that has to be made. But of course, this one, we say it in Montreal, especially, we say that this cannot be prescriptive without the predictive part.
Okay, and the predictive part is really based on the data. Is that correct?
Absolutely, yes,
okay.
Absolutely. I mean, data has been the fuel of this revolution that led the machine learning to actually overcoming the difficulties that were in which it was artificial intelligence was probably in the 90s or something like this, and then at that point the boom that we have seen in the world, and especially in Montreal with the deep learning discoveries, are structurally due to the availability of data and the possibility of using them in the best possible way. I mean, I'm actually stealing some of Joshua's talk when he talked.
Absolutely right. And computing power. In the 90s, we just didn't have the computing power that we now have. It turns out to be important because those predictive models, they need a lot of parameters, millions, billions, trillions in some cases. And so that takes a lot of computing power, and we just didn't have that in the 90s. So it's the arrival of GPUs in particular in around 2000 and in the 2000s really that started to make a difference.
Mm-hmm. Okay, so the GPUs, the computing power. Yeah, go ahead, Emma.
Yeah, maybe one thing too important in there is algorithms, right? So of course it's computing power and it's the data, but on both sides, I think that we can both agree that the algorithms play a crucial role, and the advances that have been on the algorithmic side, both for machine learning and for discrete optimization, or even on the nonlinear optimization side, the continuous one, there has been a tremendous effort and success. And these are kind of the pillars. Not only the computing power alone, the data alone can actually make us achieve what we can do today. And I think that when we're looking at the combination between these two fields, this is also extremely important. And people are talking about, at least on the discrete optimization side, so what we would refer to as mixed integer programming solvers, when you're combining the algorithmic process with the advances with the computing power increases. There are researchers, one who's called Dimitri Bertsimas at MIT, who is talking about the 200 billion speed up. 200 billion, it's like a number that you're not even, it's even hard to assess how big that is between the 90s and where we are today. And so this is obviously includes the speed up in computers, but even that is not sufficient. So there's been hundreds of thousands of times speed up just due to algorithmic work. So this is really like the research coming into play, and you're really working on the algorithms and getting these performances. On both sides.
And by the way, this is actually what the three of us are doing most of the time. So it's not that
I was going to say, that there's another ingredient that you didn't mention, which is human beings, researchers, engineers.
Very important.
Because those areas have attracted enough attention from grad students, professors, engineers in industry. They have grown so much, and that's what gave us these algorithms. It's because human beings use their brains to figure out things and try things, and that's how we've made so much progress.
Okay, so yeah, go ahead.
No, I was absolutely. I think that this is a very important. So the algorithmic side that the three of us are passionate with are actually only possible, we say before, because we have enough, let's say, brain power, and when we will be able to do it again, we will go back to our blackboards or whiteboards, depends on the preference, and still doing stuff precisely there, because this is what we are passionate with. So definitely very important point for both Emma about the algorithmic side and human brains on the other side. Yes.
Mm-hmm. So yeah, you're talking about the human brains. A lot of these human brains seem to be converging towards Montreal. I just want to know, why is Montreal so important in this new combination of ML and operations research? Why is Montreal so proeminent, and what makes it exceptional?
Well, now that Yoshua left, I can say that partially is definitely because of him. So I think that his vision. I'm one of those people that actually came to Montreal also because it was a fantastic place and a fantastic environment in which we could do things that otherwise would have been impossible to do elsewhere. So I think the vision of Yoshua definitely in the 90s when he was the one starting many things in the deep learning area, and the tradition of operation research, and at the same time the tradition of operation research that started even earlier, I would say, than definitely in the 60s or the 70s, led to a concentration of a group of talents that somehow created a boule de neige effect in a certain sense, right? You want to be here because that's a place in which you have colleagues and you have people to speak to. You have possibility of attracting other students, other talents. And then in the last 5 years, what have been amazing is that when Yoshua and I, and with the help of many others, including and especially Jean-François Cordeau, wrote the Apogée grant that led to the creation, in a certain sense, of Ivado. Ivado was already there, but changed somehow the perspective. The Apogée grant. The thing was we were hoping for having such a big impact in terms of the also companies being attracted to Montreal and the ecosystem growing, but we couldn't expect this to happen so quickly. So definitely it's an impressive achievement that has been possible only because of the collaboration between different teams. There are different many. Several places. I wouldn't say many, but there are several places in the world in which both optimization and machine learning are quite strong. But the collaborative behavior, the environment, let's say the way in which things are done in Montreal led to a completely, some impressive possibilities.
And so would other people internationally say the same thing, that Montreal is really a hub for that? Or other places would say, well, Montreal thinks they're hot, but...
Well, you know academics, right? We like to compete. So I never said, but I would say that pretty much Montreal is very well recognized. It was before, right? But it's very well recognized as one of the places or the hubs in which these two disciplines have been always very strong, but also these two disciplines have been able to get together in a way that it's way more let's say, more strict than other places in the world.
Mm-hmm. And is it Emma? Yes, go ahead.
No, I was just going to add both Andrea and I came actually from abroad to join here for work reasons. So that is, I mean, it is well known from abroad as well. But I think for me, what is a big differentiating factor for Montreal is actually something that Andrea just briefly touched upon, which is the culture in research and the collaborative culture that there is here, which is not necessarily the case everywhere else. And there are some really strong, what we would call—
This is an understatement. Sorry, this is an understatement.
Yeah, and so there are some. This is in order to call it a culture. I mean, this is something that evolved over time, and so for a long time there have been these very strong inter-university research centers that actually play, I would say, big role in bringing researchers together, professors together, students. I mean, this is an event, as you're saying, for students, but these centers, like now Mila is also an inter-university research center. You have CIRELT, which is on transportation and networks. You have GIRAD, and these are big grouping together a very big amount of students and researchers, and they do not necessarily come from the same schools. These are some, I mean, CIRELT, I think, is formed of 7 institutions. And so I think this kind of have shaped the culture in research, which is very collaborative in Montreal. And this is, I would say, at least from my perspective, is kind of unique and one of the reasons why I wanted to work here.
So even though Montreal is really focused on collaboration amongst themselves and having a lot of groups here, but I imagine you still have collaborations abroad with some groups abroad a lot also?
Yeah, because we try to convince them to come here. That's the reason why we do that.
That's the reason why. Okay, I see.
No, of course. I mean, seriously. I mean, it's a very privilege to be here and being able to collaborate with the people. But of course, we know that the knowledge is spread all over the world, even in places that you will not be considered at the top of because at the end of the day, it's just the human brains, like we were saying before. So people are unique everywhere, and then of course our role is to try to. I mean, my rule is always that if I can collaborate with somebody that is bringing to what I'm doing to a different level, there is no reason for not doing that. Actually, there is a strong incentive to do that.
Okay, so you're talking about all these people coming from abroad to come work here, and so such as yourselves, and so what do you? We've seen how important it is, especially lately, talking about diversity, how important it is to have very diverse research groups, or not only research groups, actually, a diverse population, just to have different points of view. I think, Emma, you were mentioning that as well. And so, what was my question?
The importance of diversity.
I want to know, what do you think about diversity? But all types of diversity, actually, not only diversity of, I would say, researchers coming from the same countries I think there's a lot of people from Italy coming here, for example, or the United States. Now we have people from the United States, so we have a good example. For example, in Irina Risch, who came last year. But what are your thoughts about diversity in general?
So I think, I mean, if we look at research and if we look at like the student environments and just for teaching and learning, I think that creativity and just having forums where people can be creative together is very important. And we know that different ways of thinking is good for creativity. When you put people together who are diverse in the sense of what are their thoughts, and that means that you can talk about diversity in terms of like demographics, for sure, like you were mentioning, but actually also in terms of your values, your ethics, your line of thoughts, and I think it's extremely important for learning and for research that you have this diversity, because it's good for creativity, but it also relates a bit to the culture that we were discussing before. It's not sufficient to have this diversity for being creative and for learning and getting good research ideas and so forth. It's also important to have an environment where it's free to share and where people are feeling it's good and a nice environment to share in, and where there is an acceptance for that. And so I think these are very important points for learning and for research, and we can definitely improve on diversity in terms of demographics. But I think it comes a bit, if you come from different backgrounds, kind of your thoughts and your vision of things are different. So definitely demographics play a big role, but not only demographics, just to get people who think differently together. It's important for creativity, and it's important so that what we're doing research on actually makes sense for a broader population, not only the people who are actually working on those topics.
So we've seen in machine learning, for example, we've seen some examples of unfairness, of problems going on because there wasn't enough diversity. For example, not being able to recognize, Black women's face, for example. We've seen some algorithms that were not trained properly just because of a lack of diversity. So in this case, in the case of this new field, machine learning and operations research combined, what do you think, since I think we're working hard on this diversity and making sure that we have people coming from different backgrounds, how does this help maybe? Do you think that it will make this this new field fairer in a sense? Andrea?
Well, the diversity is something that has to be improved, as Emma was pointing out, but has to be exploited, and institutions need to be there for allowing us to actually improve in this direction. So the point is that we were trying to, both Emma and I were trying to make, is that the institutions that we are working in and are institutions in which the collaboration is considered a plus, and this is the only way of improving on let's say on diversity, is when you are essentially welcoming the somebody that is not precisely equal to you, and you are putting this person in the best possible conditions to work, and favoring the fact that the others are collaborating with the new person and with the new group of people that are coming in. So this is the key point. And the collaboration is the most important one. From the technical side, Emma, please, if you want to say something, it's fine.
Yeah, I was just going to add to, in terms of like, we're working at the institutions where we're working, and it can be, encouraging diversity in all its different shapes and forms, like what Andrea was saying. But I think that we cannot hide that in the field that we're talking about, which is, mathematics and computer science, we do have an issue with the lack of diversity. We're working actively actively towards that. But I think that it takes, like earlier we were talking about collaboration and that, like, you know, you have a culture that becomes collaborative. I think we need the cultural change because this field for certain demographics that I talk about, because I'm a woman, I can talk about young girls are not necessarily dreaming about becoming a computer scientist when they are, you know, 7 years old.
Exactly, but why is
they
that?
don't even know what it is. So I think that it's not, they don't really, I think that they don't really know what are the opportunities in here, what is actually the job. And I think we have a very important work to do to teach, you know, children even younger, because we need to change the base. When we come to our institutions, this pyramid where it's becoming fewer and fewer people or diverse people, it's already, I mean, it's important, the work, but it's some sense a bit too late. We need to get the base more diverse as well. And so there are organizations like one Quebec founded organization called Kids Code Jeunesse. They're working with, you know, getting programming, learning programming already from elementary school, which I think is fantastic, because this is like really empowering the kids. They can learn how to program, create their own. It's very creative. And so students actually, since this is a student event, students can actually do volunteer work and go. And I think this is really important to reach out also to younger kids, because, you know, computers, machine learning, the apps that Yoshua was talking about, these are part of our everyday life, and they should be designed to meet the needs of a very heterogeneous population. And for that, we need, you know, diversity in those who are developing these apps.
Yes, absolutely. But at the same time, I think that Emma is touching an incredibly important point. So, I mean, why you don't want to be a computer scientist, right? I mean, essentially because you don't know what this is about. So, in the past, I think the scientists were treated in the society like people on the top of the hill, but yeah, in the labs, and some kind of isolated type of people. I mean, the fact that Yoshua goes to TV shows, and Emma goes to TV shows, and the fact that everybody is actually able to talk to a larger variety of people will make it's one of the reasons why essentially we are doing a lot of outreaching type of activity to show that what we are doing is important, but is also quite cool, right? And we are having fun doing this, and maybe we're attracting more people, and this will automatically lead to diversity. I mean, that would not be enough, but I mean, it will put the basis, the base of the possibility of attracting people that otherwise will not feel like this is an interesting or this is something for them.
Nice. And so I think
I mean, coming back, I think there was a technical part in your question, and I mean, we shouldn't forget about this. So the technical part was algorithms that do not recognize black faces or something like this. Unfortunately, the problem is data, right? I mean, if you want to learn from data, then the situation is that there will be less data related to something, and so you have to correct this from the design standpoint. So we need better algorithms that are able to learn with less data, and they're making things equitable in that direction. But I mean, if you learn from, for example, chats about sports. So think about the chat on sports without forgetting about the situation of like can be much more dangerous. But if you think about you try to learn language from chats related to sport and soccer, for example, then we'll meet a lot of people that are actually in those chats are men, and then the situation will be biased in this direction. So we need to have algorithms which are actually better in doing this and in actually using less data in order to make things equitable. And it's actually is an extremely interesting area of research on which we don't have to have the fear to say that we are not strong. So we are not doing things in the best possible way, and we need to improve very much our understanding of the issues and our ability to do things from the technical standpoint that are answering those issues.
So it's funny that you use the example of sports because, of course, as we know, there are some very high-level sports on the women's side, for example. You were talking about the fact that mainly men are on those chats.
I was clearly biased on the Italian side. I mean, that's
so
my
Italian
personal bias
men.
on the Italian side. Of course, if you talk about soccer in the United States, maybe in Canada as well, probably would be more women that are talking about this than others.
No.
But I mean, if that was my example related to Italian culture, and in the Italian culture, that would have been a man kind of thing, which is of course bad, pretty much. So it's a bad thing. In the sense of the algorithms will be biased, right? I mean, and then I'm biased as well. So, and the situation is clearly bringing to nowhere. And so we have the first thing is awareness, and then the second thing is actually the possibility of researching on this direction in order to remove this bias. But there is a technical difficulty. That's the point. We're talking about technical difficulty.
For sure. Yes, Emma.
Yeah, so maybe if I could just, if we have time, that I could add slightly to that, because I agree that there is a technical difficulty in the sense that if we could, once you have identified an issue, you can make it a technical issue and say, okay, we have identified that we have insufficient data. So now how do we deal with that fact and fact? And then there are ways to do that, right? So you can augment your data, you can sample differently and so forth, and then you're getting into these technical aspects, which are very important, and Andrea touched it on. I think that diversity, the most important part, and this is touched on when we were talking about algorithms earlier, and we said algorithms, that's actually humans. The humans are designing these algorithms. Mm-hmm. And so when we're talking about awareness and we're talking about, the big challenge is identifying the issue before it occurs, right? Because then you can actually devise algorithms such that you can address it. But often I think the lack of diversity leads to the fact that we do not identify the issue before it actually becomes an issue. So you will discover, because you see that, actually this algorithm, we rolled it out in some solution, and now we realize that actually it's completely biased because it cannot recognize the faces of Black women, say. That's too late. You should have been aware of that issue before, because the people who are designing the algorithms should think about that possible bias. And so I think that once we have identified issues,
the best would be that in the design of those algorithms will be Black women involved in such a way that the bias is not even there, right? I mean, in a certain sense, that is the ultimate goal will be that everybody. I mean, a diversity of people is involved in the development of everything in such a way that the bias is not even created from the very beginning, I would say. But this is the ultimate goal, for sure.
Good. Well, I'm getting there. I'm studying machine learning and all, and I'm getting there. Don't worry. So tell me a little bit about the future. So again, we're talking to students, we're talking to future developers of these algorithms, future industrials using all of this technology. So how do you see the future of this mix of machine learning and operations research? Where's it going? That's a tough one.
Should I? I mean, I feel that I talked a lot. So please.
Yeah, and so the thing with research and so one of the first points is that we're only grasping at the surface right now. And so I think if coming back to one of the things that Yoshua said in the beginning when he was talking about reinforcement learning. And so actually when we have an algorithm that is actually interacting to some extent with its environment and is learning. And this is a field that has had a lot of success in solving or like working on certain types of games. So people are pretty much aware of these algorithms because of the success of playing Go, for instance. I think everyone has seen, that they were an algorithm beat the world champion playing Go, and so this is reinforcement learning. And the thing is that these problems are extremely complicated when you get into a real environment, because a real environment is not like a game. The rules of the game don't change with time. The way you move on a board doesn't change with time. But when you're in a real world, the real world changes all the time. It's a highly dynamic environment with a lot of uncertainties, and that is changing. And I would say that where we are in our field, where we want to solve this very, hard decision-making problems on the OR side, while being able to learn what is going to be our environment, so kind of predicting these uncertainties in the environment, there is a tremendous amount of work that we can do in making that a lot better. And I would say that we're only at the beginning. So if one looks at, what are you going to get into this field and do contributions, that would be awesome. There are so many opportunities for the students to work on. And so for me, it's like we're only at the surface yet.
So that's exciting. That's really exciting.
It is. I think Emma is touching a very good point. We're scratching the surface of what we are able to do. Actually, the first thing has been to if you want to do recommending systems that are telling you what is the best restaurant for you, right? But at the end of the day, this is not about you and one restaurant. This is about all the restaurants and all people. So the market is given by an entire group of people and an entire that are selecting at the same time at the restaurant the same evening, and the same the offer is the group of restaurants. So essentially the assortment of the entire market is the ultimate goal. And in order to do this, of course, you need to know way more, you exploit the data way more in a more unified way, and then the environment changes, as Emma was pointing out. This is not only a static environment in which the rules are defined and once forever, and in 40 moves you win or lose a game of Go. Then the situation is way more complex. I think nevertheless optimization. Reinforcement learning is the one way of looking into this, and fortunately, it's also the strongest connection between discrete optimization and machine learning. Reinforcement learning is an area of machine learning that discrete optimizer understand. I would say not well in the sense of the technicalities, but definitely are way more familiar with than other things. So I think this is actually an area that will certainly evolve heavily, and both from the theory side and as usual, and from led to the applications.
Nice. Okay, so now that the students kind of know where ML, OR, we'll see how if it gets a name or another name. Just before we go to the last question, actually, before we go to the Q&A session, rather, I want to ask you a last question, and that's: can you tell us about your background? What did you study to get to where you are now as professors that are known around the world? Who wants to go first?
Emma, please.
Okay. Yeah, so I'm a bit of I kind of go with the flow and follow. I don't know. I did not have so if I'm talking to students now and they're thinking like, did I have a strategy with my studies and knew where I was going? The answer would definitely not. So I started out in industrial engineering and management in Sweden, and thought that I should not do computer science. And
was there a reason for that?
Well, I think at that time, I was pretty much, when I'm talking about this, maybe it was not on the map. I mean, for me, when I came, those who went into the computer science track, they were already like almost experts on programming. They had done, been programming their whole life, and I did not feel like a fit in that environment. So I went into industrial engineering and management, and then decided that I would do an exchange year in Switzerland in a school called EPFL. And then industrial engineering didn't exist, so I went in for a kind of a mix between computer science and mathematics. So I ended up in the computer science department, where I was the only woman. And I did, that was an interesting experience. And I ended up staying in Lausanne, actually, for both my master and my PhD. So I did a mix between computer science, and I did my PhD in mathematics. And so I've kind of been following what kind of my interest and curiosity brings me. And so I'm hoping now, and this is kind of something that I try to work towards, that, one does not need to feel that the environment should be diverse enough that you don't feel that you would be awkward if you go into a certain field. Like I would have felt awkward if I went into computer science, and when I started out my university studies in Sweden. Mm-hmm. So that's kind of where I ended up. So I don't necessarily have any specific diploma. It would be a mix, except my PhD, which is in mathematics, but then working at the intersection between OR and statistical learning. So a kind of a mix. So I think my word to students would be like, go with your interest, go with your passion, try to, find a path which is actually where one is interested in. And then there is always a way to kind of navigate through an educational system to be able to do that. I think there is always the way.
Nice, very nice. How about you, Andrea?
I guess it's pretty similar in the sense that I was not this kind of kids that let's say start programming at the age of 10, and then they keep going, and they do hacking on operating systems and stuff like this. I actually like it. I like these people a lot. So I've been interacting with those for most of my life. But I'm not this type of person. Actually, I was interested in science in general, and in high school I thought that I would have go to physics, and I think that was a very good idea not going there, because when I went to a faculty of engineering, I realized that I was not really understanding physics very well. So I think that was definitely a good move not doing that. And then I got passionate into mathematics when it started to be challenging and difficult, especially on the algorithmic side. I was very, very I was actually completely passionate of the algorithmic side of math in the university, in the School of Engineering. So in Italy, the discrete optimization, so applied mathematics is mostly in School of Engineering. It's just as an historical development, and then I graduated in electrical engineering, more or less, but that with a strong push at that time on the mathematical and algorithmic side, and then I did a PhD in math, and then math led me. Has been the only common denominator of everything that I've done, in the sense of coming to this area of machine learning. This is because at the end of the day, that was the best way for me to solve the math problems that I was interested in. At the end, this is, and I totally share Emma's recommendation. So just go with your curiosity and what you really feel like you're passionate with. And I think that this is not going to be like exactly the thing that you study that is going to lead where you want, but more or less the combination of your curiosity on the teachers, but this is and the professors that you you are interacting with. And of course, for the students that are doing graduate studies, the relationship, I mean, master, PhDs, but even at the university level all the time. This is the level of interaction with the professors, and the environment is making the entire difference and of course, I mean, we don't want to forget that there is the component of luck that brings you where you are, where you go at the end of the day. Tenacity and luck, and curiosity, I would say, that are the most important parts.
Definitely.
You can provoke luck and set the chances on your
side.
Right?
Absolutely, yeah. So. You can provoke luck. You can provoke luck with your curiosity and your, let's say, stubbornness in try to learn. That's the only time that at the end it works. Yes.
So just a small question. You guys you don't mention postdoc. Did you do postdocs? And are postdocs usually, are they usual? Do you see postdocs in mathematical or computer sciences?
Yes.
Because
you talk about what we did. You talk about what we did at the university.
Yeah, because you didn't mention postdocs. But you did postdocs,
I mean,
right?
I've been a late postdoc at New York at the math science at IBM, and yes, this is one part of my career, and then the interaction with postdocs is, of course, one of the most, let's say, the funniest part of our job, definitely. But I mean, we at least I feel. The reason it's fun is that you feel less responsible of what they will achieve in life, right? I mean, they are kind of already
researchers.
well-shaped researchers that are coming, and I treat them completely like colleagues without any. I mean, of course, I treat the students, the master and the PhD students, as colleagues more or less as well. But I mean, I feel the responsibility of them to achieve something under my guidance. The postdocs are a different type of creatures in a certain sense.
For sure. So you as well, Emma? You did a postdoc there?
I did 1 year. So combining having children and postdoc, and before starting my my first position. So I think maybe it was a year. I'm not sure. Like in reality, given parental leave and such, it was actually can be counted as a year, but. I did have a gap between my PhD and starting as a professor in Stockholm, Sweden. Actually, I did 4 years before as a professor slash postdoc before joining Université de Montréal.
So you're talking about trying to do a postdoc and having a baby at the same time, the studies, high-level studies, and having a family at the same time for women is obviously, I could talk about that too. So that's for another panel. Okay, We'll organize that. All right, so I think we have some questions, and we will go now to the questions that we have received. So we have a question here from Melanie Delgado. I'll just read it to you, and then you can answer as you please. So there are many tools that make machine learning accessible to a wider public. Libraries like scikit-learn and TensorFlow and Keras. But operations research is still more difficult to access to non-initiated folks. What are your thoughts on the democratization of operations research so it can be widely used like machine learning?
Well, this is an excellent question. I think that there are plenty of, considering, if I look back at when I started, there are plenty of tools that are actually, you can play with in order to solve discrete optimization problems, including the ones that I was mentioning, IBM and others. Some of them are actually, commercial, so you have to pay for, but in academia we get them for free. So this is a way the democratization that happened during the time in which since I started. So we are already in a better shape. The modeling component is making the difference. So somehow I think you can get to a point of doing experiments with machine learning tools in a relatively shorter amount of time than what you need to come up with decent to good models for a discrete optimization. And this is the reason why they may be a little bit less accessible to people. So I think they require mathematical knowledge that sometimes can be achieved in a slightly longer amount of time in terms of the modeling. So as soon as if somebody is telling you about a problem, that the first, the understanding of the kind of understanding of statistical characteristics is probably slightly faster than what you can get in the way in which you will need to write down a model for modeling the problem itself as an optimization problem and then solving it. So I think this is the barrier that is making it less straightforward. But in terms of software, there is plenty of software now for discrete optimization in the internet, and and a large part of it is free and can be used by students very easily.
Mm-hmm. Yeah, so I think though that as a community there has not been a sufficient effort in that. I mean, we could definitely improve. There are certain problems. So I totally agree with Andrea that if you have a specific problem and you have to go through the mathematical modeling, that definitely makes it more inaccessible. Even if the solvers are accessible, you still have to write down your mathematical model. But there are mathematical models for generic problems, things about, traveling salesman problem, vehicle routing, these kinds of, where you can find a variant that actually probably fits the problem you're interested in. And there has been less effort, I guess, from the OR side on making those more accessible and explaining. I mean, in machine learning, you can find all kinds of blogs and very easily accessible where you kind of not dumb it down, but you're speaking a language such that it makes it easier to access. I think there are efforts like that, and there's definitely resources, but not to the same extent. So I think as a community, we should also, try to make those efforts.
Well, I think that historically speaking, I would say that the efforts like this, I've seen efforts like this, but sometimes they failed. So, I mean, to be fully honest, the situation is that there is this barrier of the mathematical ingredient that makes every beast, like an optimization problem, is quite different from another. So you can cast it one way or the other. But then the theory tells you that, there is a theory in discrete optimization that's called the NP hardness theory. It says in very short, at the core, it says that every problem is exactly equivalent to the other, can be transformed in polynomial time one from the other to the other. But the problem is that if you try to solve problem A with a tool that has been developed for problem B that in theory is equivalent, you will fail miserably. So this is a part that is a wall that we hit if we want to do something like this. And I saw multiple, tries, even from software companies, to say, okay, just give us the constraints of the problem. We're going to write down a model for you, and all this have been not very successful. So can we go there? Potentially, but that's. I can say that, yes, partially maybe the community has not been so active, partially there have been failures in this direction.
All right.
And I can remember those because I'm way older than Emma, of course, but this is a different story.
Way older. I'd just like to remind everybody that if you have questions for our panelists, don't hesitate to go into the questions box, Q&A box, and write your question there. So we have a question here in French. That's okay, or yes, of course. Alors, Patrick nous écrit comment comparez-vous l'apprentissage par renforcement et la recherche opérationnelle? Exemple, optimisation de boîte noire pour la prise de décision. Quelles sont les forces et quelles sont les faiblesses?
So if we transform this, so what are the differences between reinforcement learning, la différence entre l'apprentissage par renforcement et la recherche opérationnelle?
Comment comparez-vous l'apprentissage par renforcement et la recherche opérationnelle? Exactement, pour la prise de décision.
Pour la prise de décision. So how do we compare reinforcement learning and operations research for decision making? So actually, this is a very nice question, and there is quite a new book by Dimitri Bertsekas that is called Optimal Control in Reinforcement Learning. And actually, these two. So if we're looking at operations research, is a very broad, field. And as we mentioned earlier, you have like continuous nonlinear optimization, which is actually part of machine learning, but then you also have a collection of techniques and methodologies, and one of this is called like dynamic programming or optimal control, and this is very connected to what is called reinforcement learning. And so there is even this recent book that I mentioned that is talking about the similarities between the two. So these are essentially similar techniques for solving sequential decision-making problems. So this is what they have in common. And if I'm going to go very high level, what usually distinguishes these two, but is the learning part, right? So if I have what one would call deep reinforcement learning, then you would have this optimization techniques that go sequentially, very similar to the dynamic programming and optimal control one, but you have a component where you're actually doing machine learning inside there, and the machine learning is giving you information on how good your next decisions are going to be, in essence. And so you're kind of combining this learning part with the sequential optimization part. And actually, some of these techniques are very similar, but they have different names, and they come from the two fields. So there's something from operations research that is called approximate dynamic programming, where there is also a lot of learning going on. So actually, more recently, researchers have been looking at connecting these fields and also like seeing what are the techniques that perhaps even and there are even techniques that have different names, but actually they are the same in the two. So there's kind of the communities historically have been, evolving a bit separately. So I would say that there are different techniques, but they can use to be solved somewhat similar decision-making problems. And there are also really intersections between the two. Andrea, I don't know if you want to continue.
No, I mean, I think it's perfect. The answer is absolutely correct. I think there are only two things. So this is the reason why I was mentioning before that reinforcement learning is understood from discrete optimizers, because they have, a common root and common, let's say, background on dynamic programming, which is the basis of most of what the discrete optimizers are doing. So that's why I was mentioning this before. And so it's a good question to complement and saying this. I mean, on the other hand, it gives me the opportunity to say that we're talking a lot about this intersection of machine learning and optimization. As every new discipline, we are facing what Emma was telling a second ago. So we rediscover things that others have been discovering in other disciplines multiple times, and putting things together and making sure that we fully understand each other in the language, and getting to a point in which the understanding is complete is far from trivial. So this is a part that is common to every time two scientific disciplines are starting to collaborate and developing a new discipline, that we can think about this as a new discipline. Then they have to actually do some preliminary steps to understanding one each other, and this leads to some slowdown and sometimes some hard, let's say, walls to hit from the scientist in terms of, let's say, to be conservative. Facing conservativeness and so on and so forth. But I mean, this is something we're working on, of course.
Yeah, nice. So we have another question by Sami Shauki, who says, "Thank you for this amazing talk. happy to hear you talk about inclusion and the importance of culture ethics at the root of designing our new technologies. Talking about diversity of perspectives, what do you think is the space for creatives in the process of building these technologies?
I think that I think Emma touched it very well before. So the creativeness comes from, part of the creativity comes from this diversity opportunity, right? Listening and people having a different perspective that you are. In terms of creativity, I think it is. The space. I used to. I believe quite strongly that scientists are not very different from, even engineering or mathematics that look like a very, let's say, very rational type of discipline. So they require a huge amount of creativity in order to achieve new frontiers. And so in that sense, I think is not because you are rational and you're looking for rational explanations, you don't have to be creative, otherwise you will not really find much. And so in that sense, I think this is very connected to art, for example. So where people are creative in art, I can talk to them very easily because we have the same state of mind and try to go beyond the classical rules or beyond the let's say the environment or beyond the limits that you currently see. And so in that sense, I think creativity is a fundamental part for whatever we are doing. So I would say the role is central. I don't know if it answers the questions, but I would say definitely that.
I definitely think it's a good response. Emma, do you want to? Do you have something to say about that? About creativity?
No, I second what Andrea was saying, and I was mentioning it earlier. For me, creativity. This is what it's about. And when we're talking about these algorithmic speed-ups before and the humans behind these are highly creative people who are kind of looking at the same problem from different angles. And so if you're not if this is not achievable without being creative. So creativity is at the heart of what we're doing. Huh?
Yeah, it's thinking outside of the box somehow. And being very stubborn. I would say that's the other part.
For sure. So it's funny how usually we think science is not creative, whereas arts are creative, right? But what you're saying is that no, this creativity, and I think this is what Sami was saying also. You do need this creativity to develop innovative new technologies. It really is part of it as well.
Yeah,
but usually it's always considered separate.
It is. I think this is a certain sense quite. I don't know, mistake. It's a conceptual bias, I would say. It's a situation in which when we try to prove theorems or to make to design an algorithm that is actually doing. Solving a problem that was unsolvable before, we really needed to use our brain in multiple ways, right? It's one way is to be very, I would say before, very stuck and very stubborn in terms of wants to explanations for what is happening, and on the other hand, to not stick with the basic explanation and going beyond this. So then. That I think is actually what creativity is about. So, going beyond the limits that are currently into the table.
For sure. So we have a question here coming from someone that we all know, Gilles Savard, who is the big boss of IVADO.
This one will be hard.
Okay, let's prepare. So Gilles asks, before the advent of intelligent algorithms, we didn't really talk about bias in the decisions people made. Won't algorithms and our new ability to better understand data and awareness of bias help reduce bias in the future rather than increase it?
Well, I think that the
better get it right.
So, exactly. So I'm not sure that I would say that the type of algorithms that we were developing before were affecting less how could I say? They were affecting less clearly the day-by-day life of people. So when I was saying that optimization was a very well-kept secret, I think that this is the case. I mean, optimization is what discrete optimization is what makes power grids working in such a way that you can switch on the light in your apartment and getting light, right? I mean, this is exactly what we are doing, but it's not perceived by the public like, oh, wow, this is what is happening on the background, right? I mean, this is but exactly this. I mean, it's the achievement of having a power grids that are working and giving you light and power and whatever else at any point in time is a big achievement that the people don't talk about very much. On the other end, the fact of I mean, using your cell phone for communication and so on and so forth, that what the type of applications that the machine learning has been pervasive in the last 10 years that Yoshua was pointing out, and the use, for example, of machine learning in trials, and from the police and so on and so forth, makes the thing extremely visible from the general public, and so making an algorithm deciding who is going to win a particular bid. Of course, this is a different situation, and so the situation comes to the price of being very much exposed to what you are doing, much more than what we were doing before. So I think the reason why we're talking about this now, and we were not talking about that before, I think is the type of application that we are facing now. And the second part of the question is, can we? I think my interpretation of the second part of the question is, can we do better? And the answer is yes. We can do definitely better.
Can always do better.
But Emma,
yeah, I'm a bit intrigued by the question of bias as well, which I'm not sure that you responded to, and I'm not sure I completely get the question in terms of the bias. I think I'm not sure if I'm interpreting right, but I'm going to talk about one component that I think is important for kind of like intelligent algorithms. When they become data driven, it means that they're also creating their own data, right? And so we can think about algorithms that are trying to change the way people are behaving in the sense of the recommendations they are making. People are looking at these and they're creating their data by showing their preferences about what they like and so forth. And this kind of reinforces the algorithms again, and they learn more and more. And so there is a sense in that. So Gilles was referring to bias. There is, I'm not sure how to interpret the bias question, but I think one of the aspects here is that we're kind of influencing through algorithms how people are behaving. And I think one ethical aspect of this, and it relates to the discussions we've been having about how we're developing these algorithms and who are developing them and for whom, yeah. I think it's important to ask oneself the question as to how do you actually want to influence people and for what purpose? And how are you learning about their behavior? And something that I'm particularly interested in is trying to understand, for instance, how should you design transport services, but sustainable transport services, so that they meet people's needs and can kind of influence people to behave in an environmentally more sustainable manner. And in that case, influencing people and kind of driving behavioral change can be something very positive, but it can also be something negative. And so I think there are very important ethical aspects in here. And so as your algorithms are becoming more and more data driven, they are they're interacting with their environment and you're learning again, there are, ethical aspects, and if one calls that bias, I'm not sure if that was what Gilles was having in mind, but I think there is an important part here in the way we are designing those algorithms and what are kind of the behavior the behavioral changes that we're giving incentives to do.
Okay. We have here another question by Melanie Delgado. And it goes like this: as a data scientist who is highly interested in operations research, what do you advise me to continue the exploration of operations research without coming back to academia full time? So let me say that again. So as a data scientist who is highly interested in operations research, I think what she meant to say is, would you advise me to continue the exploration of operations research without coming back to academia full time? And then she added a PS. I used CPLEX or CPLEX. CPLEX during my master's and really liked it. But many organizations don't have it among their software, unfortunately. So what do you have to say about that?
Well, the background I'm reading, but I'm not so sure if it's true, is that she works as a data scientist, and she wants to know if after the master, and she wants to know if it would be better for her to get a PhD, right? I mean, that's my interpretation of the question.
I imagine that's a big question.
But I don't know if it is correct or not. What could I say? Getting a PhD was a lot of fun for me, so I used it very much. So I would not recommend anyone to not do it. At the other end, I don't know. I mean, there are many personal questions that will be asked in order to assert completely this thing. So getting even higher education is always advisable. But I mean, if she likes, for example, working on applied problems, I think that she can get a lot of additional education by resources, online resources, by actually experience in working with several type of maybe changing environment and jobs and doing different things in a relatively short amount of time, and not staying in the same company for 20 years or something like this. I mean, I don't think, just to say that this is not the only way of becoming an expert in operation research. So this is academia is not the only way.
So definitely she could eventually go to industry and continue there. I think there's also some PhDs that maybe can be done in the industry.
Of course, yes. Yeah. Emma was pointing this out before. So there are some students that are starting with us and they are not particularly interested in, let's say, theoretical or pure theory questions. I mean, well, I never start with a PhD student having in mind if this person is going to stay in academia or go into industry, right? This is so it's not a discipline in which we have to switch immediately. There are probably other disciplines in which, most of the jobs are in academia or most of the jobs are in industry. We are in a situation in which I would say that there is I'm not saying 50-50, but I mean, the chances of the person starting and realizing over time if he or she is more interested in the academic job or in an industry job is a decision that comes over time.
So I think it's also one important aspect is to kind of self-assess and see, do I want to be a user of these methodologies? So just being able to know sufficiently so that, I can formulate a mathematical model, I can use a solver and so forth, but kind of not, going into not being labeled as an expert on OR, going like on more sophisticated methodologies and so we're going beyond what is like the the off-the-shelf kind of solvers can do. And so I think if the idea is to become a more advanced user, there are different, shorter educations that can be done. And I know IVADO has been organizing excellent, more shorter courses and so forth. So I would say that it's a question of, what are the personal interests and so forth, and becoming a data scientist who is an expert on OR. If in addition one has machine learning, this is something like for industrial applications it's a strength, and it's something that at least I see as part of the work as a consultant. This is something that is extremely valuable to industry. Now, there are different ways of doing that, and people typically don't do 2 PhDs, one in machine learning, one in OR. Some of the recent that we are having are working at the intersection, but otherwise it's always possible, to take shorter courses and kind of gain sufficient knowledge to become an advanced user.
Mm-hmm. Okay. So we have another question here by Rosemarie Viana. And this is interesting because she has a question more about the health sector, and we didn't really talk about it so much. How can a pharmacologist or a pharmacist use the learning offered in the IVADO training program? Okay, I guess that's more of a question for me. But maybe we can touch the aspect of health and how machine learning and OR is used in the health sector, and then I'll answer that question more specifically. But I think that very often, go ahead.
That question is certainly connected to this professional masters that the University of Montreal is definitely offering, in which the people can take. Becoming like people that have lost a lot of interest in a particular sector can get educated in part in computer science and mathematics in order to actually improve in their abilities in the area in which they are caring about. For example, pharmacology or healthcare in general. So I think this is part of the answer. In terms of the healthcare as a general topic, I'm personally working a lot on that part. Especially in transplantation, so kidney allocation in particular, and both from the perspective of the prediction of the quality of a donation, but also in terms of more, let's say, this, which is more ML oriented or more OR-oriented, so operation research-oriented, is the allocation of kidneys in the best possible way in order to actually use the resources very well. It's called a kidney exchange, when there is a group of, when essentially you need a person needs a kidney transplantation, and as somebody in the family, for example, or in the relatives that are actually willing to give the kidney, but the two are incompatible, then you enter into what is called an exchange, and so you build a chain in which one person is giving an organ to somebody else, but the person that is willing to, let's say, person A as a sibling or as a family member that wants to give an organ to this person, but is not, the two of them are not compatible. So instead of giving my organ to patient A, I'm going to give it to patient B, that on the other hand has another person that is willing to give the organ and is also incompatible, that will give it to me as a patient A. So there is an exchange that is created, and in order to maximize the possibility of people to receive organs and being healthy, that is a mathematical optimization problem that is underlined, and then we are studying these kind of things. So it goes, before I was mentioning very widely logistics for healthcare, so making hospitals more efficient and better organized. But there are plenty of questions in healthcare that require both machine learning, so prediction, and discrete optimization, so decision making, and it's going to be like drug discovery and many others.
Mm-hmm. So maybe I can answer also the question about the courses offered at IVADO. So of course, we do have courses that are destined to people that have a scientific background. And so pharmacists, of course, and people who have worked in pharmacology in the lab, for example, are definitely have the background to take our courses. But usually I'd say in the biomedical field, people have no knowledge or not very much knowledge of programming. And so definitely that's something to go try to get before taking our courses. And so also I want you to know, Rosemary Viana, that we are definitely working with Barbara Dessel, who is an advisor here at IVADO and who specifically takes care of the health sector for all the students and all the people working in the health sector that want to become more knowledgeable in machine learning, deep learning, or have more advanced data science techniques. So definitely contact her in order to know how you can be more knowledgeable in this field. So thank you for your question. We have a last question for you. I hope you're not too tired.
No, we're
fine.
okay.
You guys are okay.
I say we.
Yeah, we're okay. Andrea, you didn't move. You said that you can't move more. You can't stay.
I did. When Emma was speaking, I was moving it up. Yes.
So last question by Nancy Laramé, who asks, what fields or sectors of the society do you think would have the most advantage to use and combine machine learning and operations research?
So
for sectors of society.
In terms of sectors, I think it's very hard to say which ones would be the best. I think that it's important to understand that when it comes to leveraging machine learning, we need, like we said earlier, a lot of data. But actually, a lot of data is not necessarily sufficient. You need to have, good data, high quality data. And so I would say that, within a given sector, there can be, companies or organizations that have taken better care of their data than others. But this is definitely, one direction for which sector that could benefit. I know that, for instance, the health sector that we were talking about earlier, it can be very country dependent, or how well organized the data is and to what extent the quality is. I know for transportation and supply chain, this is also a question. When the data is there, however, many of the organizations are low tech in comparison to, a high tech company focusing on some AI solution or machine learning solution. So typically there can be a very, large gain in leveraging optimization and machine learning for decision-making problems that they can face. So if there are tough decision-making problems that there are in the transport sector, for instance, health sector, like Andrea was mentioning, then there is definitely a benefit. But this is, there are several sectors. We haven't talked about finance either here today. And so
true, indeed.
Andrea, I don't know if you have other sectors in mind, but for me, it's more of a data maturity question.
Yes, certainly is the intersection is related to the fact that you have data and then you have essentially a decision-making process that is actually driven by data. So if this is the case, I think it is the techniques can be applied in a very agnostic type of way. So there is we don't study these kind of things by having a particular sector in mind, but we, of course, study them having a particular data set, data type in mind. So if you have time series that Yoshua was mentioning before, of course, we will do different things that if you have, labels given by recognition of individuals over preferences or other things like this. So there will be very much, I think, related to the data type that you are working with. But at the same time, I think the important part is associated with the fact that you have at the end you have a decision-making process for which predicting only is not enough, right? Just having a prediction of there's going to be the next the next, let's say, interesting evolution of the market still require at the end to make an allocation of the resources, and then if there is an allocation of a scarce resource, then discrete optimization comes into the play.
Okay, well, I'm very, very, very happy for your presence, because this was a very interesting panel. And I certainly hope that the students that are listening, as well as other people also, really got, you know, a good idea of this new methodology, this new technology called MLOR. That's the new name, okay? And that actually had some ideas for, you know, what you want to do later on and how to do it. Maybe we're inspired with our researchers here, our professors here, with their paths. So maybe that you can take some, not necessarily the same path, but some kind of a similar path, but in your own way, so that you can join this great community. So thank you so much. Before we leave, I have a few words, and this is something I probably should have done at the beginning, but I decided to do it at the end. So it's just a little presentation of IVADO. A lot of people sometimes ask, well, what is IVADO? What is that thing? We have, you know, we're very suspicious sometimes. We're not too sure what IVADO is. Well, IVADO is actually a Quebec-wide collaborative institute that works in the field of digital intelligence, and that is dedicated to transforming new scientific discoveries into concrete applications that benefit all of society, actually. And so what we do is that we bridge the industrial and the academic worlds. That's why we were talking about those two so much. We bridge those two environments so that they work together, very closely together. And we make sure that all the experts from various fields are actually trained in digital intelligence by some of our prominent researchers. And today, IVADO is very proud of having presented 3 of its professors from its ecosystem. And also what is very important, and I hope that you saw this today, is that for IVADO, the students are also very important. We like to put them forth to encourage them to be part of our activities, but as well to do things for them. And so please don't hesitate to contact us at IVADO and make sure that you contribute also to all of this that's happening here in Montreal. So just a few thank you notes now. I'd like to, first of all, thank the organizers of the event. First of all, Alexandre Gertin-Pasquier, who is the student advisor here at IVADO. So if you really want to participate, you want to know what are we doing for students here, definitely contact Alexandre Gertin-Pasquier. Also, thank you, Sophie Côté, Guillaume Chiquan, and a whole bunch of other people at IVADO who participated in the preparation of this great event. I want to thank also the diffusion platform, Agence Web Diffusion, with their very professional ways. My God, I was so impressed. I think you were as well. So thank you to
Definitely.
them. And thank you to the public for being here, for listening. Don't forget to be curious and to take part in the other activities throughout the month, to go see the student presentations and maybe learn, maybe discover new things, maybe find some new collaborations also. That's always a really good thing. So don't be shy and make sure that you go to those presentations, and you can get all the information on our website at ivado.ca. For those of you who are interested in operations research, we have a school. IVADO has a school coming up somewhere in the spring of 2021 called the Première École en Sciences de la Décision et Recherche opérationnelle. So make sure to follow us. It should happen soon. So that's if you're interested. And finally, of course, big thanks to our panelists, Emma Frejinger. Oh,
Frejinger, yes.
Frejinger.
Not easy.
Frejinger. Thank you to Yoshua Bengio as well. He's immobile. Thank you. And Andrea Lodi, we really thank you for accepting this proposition of talking to the students. I think it's always very inspirational for them. So thank you.
Thank you. It was our pleasure.
My pleasure. Yeah.
Bye-bye.
Just a moment. Oh. One last thing. You know how usually we have a after conference. Well, we clap first of all. Can't you hear all the claps? Everybody's clapping right now. We get up and then we go to the back of the room and we start mingling, talking, networking, exchanging. Unfortunately, when we're online, we kind of lose that. We don't have that. We just click exit the call, and then that's it. We're off to whatever else. But if you wish to pursue the discussion right now after this conference, we definitely invite you to attend a networking event on the Gather platform. And this event is organized by the Student Association Polytechnique, with whom we collaborate. And so the link to this event should be in the chat. I believe you should have the link in the chat. Do you see that? I imagine it should be in the chat. If not, you can go on Facebook to definitely go see Poly.ai and their event, networking event. So it's always good to exchange after having such a great event. I think it's very important. So once again, thank you very much, and happy Digital October, everyone. Bye-bye.
Thank you.
Thank you.
Bye.